Tyler, I missed the beginning. Can you catch me up to what's going on right now?
Oh, why, of course. Now, it's a pretty simple way to do this. But this right here is a Mexican jumping bean. Now, on a sunny day, the theta of the Mexican jumping bean is this. Now, on a cloudy day, not to be confused with a CO2 day, this is the angle of the Mexican jumping bean. Now, CO2 plus K equals 9,000 moles of moles. That is furry creatures, 900,000 moles of furry creatures, which we have this big mole right here. His name is Monty. And as you can see, he is about 40 times the size of the Earth. And in this diagram of moles to Earth, this must be the moon, which means the moon is actually bean. Moon is bean. That's key for this equation. Now, we call that the moon bean, okay? It's a critical part of elementary particle physics and quantum mechanics. Now, right here, this is the guy who launched the Mexican jumping bean in the first place. We call him Dr. Bowtie, okay? Now, it isn't until later that you learn that Dr. Bowtie is actually just a lollipop, and we don't know how many licks it takes to get to the center. Now, everybody knows that ducks are better at licking lollipops than any human being can, so we hired this duck here to do it for us. Now, since ducks always carry keychains on their feathers, he has one on his wing because he has to be a normal duck. So his leg here, as you can see, looks like an L, which is actually equal to the unit of duck times L, where we assume that L is lightly salted pretzels. So this is a duck lightly salted, and when we use the quadrinomial x equals green over sun equation, we can deduce that NaCl is actually pronounced knackle, and we've been doing it wrong for hundreds of years. Oh dear, that was unaccounted for in calculations. Okay, so that idea, as you can see, that idea was sad. Now that idea of sad equals the square root of a square root. Now, everybody knows that when they're derooted, squares become sad because a square without a root can't exist. So that idea is sad. Coincidentally, this square is sad. Now, this duck being salted, ignore that. But it means that since L is lightly salted, the question arises, what are we looking for? We're actually #finding Reese. Now, who is Reese? And why is everyone eating her pieces? Is she okay with this? We don't know. We have to find her to ask her. That's how we know. Now, well, funny story. This is actually incorrect right here. This is a 4. Sorry about that. So what happens basically when you're looking for Reese is you start out with Reese equals L. That's what we deduced in the first equation. Reese is salty because we're eating Reese's, who wouldn't be salty if we were eating candy. Now, it turns out that the equation that we tried to use to deduct who Reese was had a hole in the bracket, okay? So the data leaked out the parentheses, and it goes into what's called the data pool. The data pool is where all the data that you lost goes, and it's no offense against you, but the data pool is here. And who has to manage the data pool? Well, the data pool is actually in the data cave, the dark data cave, managed by Data Dave. So Data Dave, in his dark data cave, has to manage all the data pool that came out of your data parenthesis hole. Now, as you can see, Data Dave is not happy. And as we deduce, not happy is equal to sad, which is equal to square, so Data Dave is a square. Now, it's a well-known fact that Reese is actually a big fan of candy canes and Christmas. But since this is the number of candy canes over B, and if we assume B is an elementary constant, then we can deduce that Data Dave is growing the candy canes to get Reese to come to the candy canes so that we can find out who Reese is. However, Data Dave developed an affinity for candy canes, and he seems to have consumed them all. And as deduced by this equation, Data Dave has become quite voluminous from his candy cane consuming endeavors, and he is now a circle. So basically what happens with that is he goes to here. Anyone want to tell me what that is? Nobody? So this is actually the new shape of Data Dave, because circles equal happiness if squares equal sadness. Now, what does this look like to you? If you set a binary tree, you are partially correct. So what happens when we go through this binary tree, it actually spells out the word M, muffin. Now this muffin, if you were to incorrectly perform the muffin calculation, you would deduce that it was actually a banana nut muffin, which of course is erroneous. And so, since you've added this extra fruit here, that goes into the data pool, okay? Because extra fruit is not good. It moves about 1,000% errors in your error units, okay? Now when that is produced, it drains all the way back down into the data tree, which it's getting top heavy because of all the banana juice. So when you turn it up over, you start getting a binary tree that goes up like this, right? Which actually resembles a rabbit. See that? See how it's cute and furry and adorable and you love it, but it's an error. Right?
I have a question. In the top corner where it says rabbit over infinity.
We're getting there. So when you have the rabbit tree, it starts, see the thing with rabbit trees is they go like this, right? But they have an error because they start multiplying too fast. That's why nobody uses rabbit data trees. And so they start going so fast they form what's called the infinity cloud, which is different from the rabbit cloud over infinity. Different also from the danger zone in the uninfinity cloud. And if you get these mixed up, everything's ruined and everything doesn't work.